We are now doing part 4 of Chapter 1 review. This starts on the bottom of page 63 in your textbook, number 32. It takes 3 hours for a train to travel 175 miles. What is the average speed of the train? Now, you need to remember that distance equals rate times time. So if I plug these numbers into that formula, my total distance was 175 miles. And that equals, the rate is actually what we're looking for. Rate is another name for speed. So that's what we're looking for. And then my time is 3 hours. So I have 175 equals r times 3. If I'm going to solve that, I would divide both sides by 3. So then I end up with r equals, 3 goes into 175, 3 goes into 17 5 times, and there'd be 2 left over. So you'd add that to the 5. 3 goes into 25 8 times, and there would be 1 left over. So you think about having a 0 there, carry the 1. 3 goes into 10 3 times, and that's going to happen repeatedly. So it would be 58.3. So I would say it is about 58.3, and this is going to be measured in miles per hour, because those are our labels, miles and hours. So that would be my answer for 32. 33. While on vacation, your family rented a car for $293. The car rental costs $180 plus 25 cents for every mile driven over 150 miles. How many miles did you drive while on vacation? Well, we start with, let X be your miles over 150. Then if I write the equation, I'm going to take 0.25 for the 25 cents for every mile over 150, so 0.25x. Plus, you have an initial fee for the cost of the rental car right up front, and that's $180. And then you're going to equal your total cost of $293. So that's my equation. Now I'm going to subtract 180, and then I divide by 0.25, so I find out that x equals 452. That leads us to, the family went 452 miles over 150. So then the total miles driven is 452 plus the 150 that you got without any fees, so it would be a total of 602 miles. Number 34, solve the inequality, then graph the solution. We're going to skip number 34 because a lot of these are going to be the same type of steps. Remember when we talked about comparing inequalities and equations? The steps are still the same. So for number 35, if I'm going to go through and solve this one for x, my first step would be to subtract 7 on both sides. So then these 7s would cancel each other. I'd have negative 3x is greater than or equal to negative 18. Now we have to divide both sides by negative 3. So see, the steps are the same as equations. These factor out, so I end up with x. Now here's where you always have to think a little bit. Did I divide by a negative? And you got to think about it, it's what you divide by. So these right here, I divided by negative 3. When you do that, you have to flip the inequality symbol. So that turns into less than or equal to, and then 2 negatives make a positive, so this is going to be positive 6. So there's my answer, my solution to the inequality. Now if I go up to graph it, we're going to find 6 on the number line. That's right here. Now you need to decide, is that going to be a solid dot or an open dot? And this one's going to be solid, so you have to fill it in because there is an equal sign on the inequality. Now, when is x less than or equal to 6? That's going to be to the left of the dot. So I'm going to draw an arrow going all the way to the left of the dot. Number 36. Now we have x's on both sides. So the first thing I would do is put the x's on the same side. So I'm going to subtract the 9x. 15 minus 9 is 6, so I'd have 6x plus 8 is greater than, these cancel, so I'd have negative 22. Now we're going to subtract 8 from both sides. So we've got 6x, these are gone, is greater than negative 30. Now we divide by 6. So the 6's factor out, and I end up with 1x. This time, I divided by positive 6. So the symbol's going to stay the same. Greater than, and that's going to be negative 5. So there's my solution to the inequality. Now if I were to graph it, this time notice there's no equal sign on the inequality symbol. So I need to put an open dot on negative 5. Okay, open dot on negative 5 because there's no equal sign. And when is x greater than negative 5? That's going to be to the right on the number line. So I would draw a line with an arrow going to the right. 37 we're going to skip. That's a lot like the last problem we just did. Number 38. This time we have a compound inequality. Notice that there are two less than symbols. We're going to start with the part in the middle. Always look for the part where there's an x. Okay, that's in the middle. The first thing I would have to do to get x by itself is subtract the 10. But now we have to do that in 3 places. I need to do it to the left of the inequality symbol, and I need to do that to the right of the inequality symbol. So I'm going to subtract 10 from 3 places. So here I have negative 15 is less than, these are going to cancel each other out. Now I have a negative x is less than, and 5 minus 10 is negative 5. Then ask yourself, is x by itself? In this situation, it's actually not. We need to get rid of that negative. So I'm going to divide everything by negative 1. So that leaves me with positive 15. Again, think to yourself, we just divided by a negative. So I'm going to have to flip the symbols. So that leaves me with positive x in the middle, flip the symbol, and positive 5 on this side. Okay? Now what this is saying is that x is between 5 and 15. Now remember with number lines we talked about, we want to go by the same thing all the time. For this problem, I'm going to go by 5s. It just seems to make sense to me. So each of my hash marks are worth 5. Once I've done enough of those so that I can tell where the hash marks are, that's fine. Notice we have 15. There's no equal sign, so that's going to be an open dot. And we have a dot at 5. Again, no equal sign, so that's going to be open. And then it says that x is less than 15 and greater than 5. So it's going to be all this area in between the two. X is between 5 and 15. Number 39. This one works very much the same as number 38. We need to subtract the 1 first. So I'm going to subtract 1. Make sure you do that from all 3 things. So I've got negative 9 is less than or equal to 3x is less than or equal to 9. Now we have to divide everything by 3 to get x by itself. Negative 9 divided by 3 is negative 3 is less than or equal to x is less than or equal to positive 3. Okay? Now that's the answer to solving the inequality, compound inequality. This time we need to close our dots because there are equal signs. So I'm going to put a closed dot at negative 3, closed dot at positive 3, and then we draw a line in between because x is between the two. Number 40. A triangle has sides of lengths 10, 2x, and 3x. The sum of the lengths of any two sides is greater than the length of the third side. Write and solve 3 inequalities to find the possible values of x. First of all, it says that 2 sides are always greater than the length of the third side. So my first inequality would be 10 plus 2x is greater than 3x. My second inequality, I would take the 10 and the 3x, add them together, they'd be greater than 2x. And then the last part, I would take the 2x and the 3x, add those together, it'd be greater than 10. Notice it also says to solve those. So for the first one, I would first subtract the 2x so that the x's are all on one side. So I'd end up with 10 is greater than x. These guys canceled out. There's my first inequality. 10 is greater than x. Then I would take the next one, again, get the x's on both sides, on one side, excuse me. So I'd end up with 10, these are gone, is greater than negative x. This time I'm going to have to divide by -1 to get rid of that negative in front of the x. So I end up with -10. We divided by negative, so I have to flip the symbol. So -10 is less than x, or x is greater than -10. And then for the last one, first combine the x's, so we have 5x is greater than 10. Then all you have to do is divide both sides by 5. So you'd have x is greater than 2. So we wrote all three inequalities and then we solved them. Now that we have these three inequalities, we need to find the possible values of x. So if you look at the first inequality, it says 10 is greater than x. That is also x is less than 10. So that would be an open dot at 10 going to the left. The next inequality says that -10 is less than x, or that means that x is greater than -10. So you'd graph it like I have on the number line. And then you look at x is greater than 2, that would be an open dot at 2, and that would be going to the right. Now what you need to do is look at all three of those inequalities and think about where do they meet. They actually only meet in this section right here. So if we write that as a compound inequality, it would be x is between +2 and +10. So that would be our answer for number 40. Solve the equation. Check for extraneous solutions. There are times when we will go through and solve these and we can plug the solutions back in and they're not always going to work. So we always need to make sure that we go back and check. Now, with absolute values, these kind of turn out interesting because you can have two different answers. 3p plus 2 could be +7, or 3p plus 2 could be -7, because the absolute value of 7 is 7, and the absolute value of -7 is 7. So now what you would do is you would just go through and solve both of these. So I would subtract 2 from both sides. So 3p equals 5. Divide by 3. So p is 5/3. Or, make sure you solve the other one. Subtract 2. So 3p equals -9. Divide both sides by 3. P equals -3. So this would be your final answer. You'd have two answers because of the absolute value symbol. Number 42 works very much the same way. First we start out with 9q minus 5 equals 2q, or 9q minus 5 equals -2q. The first thing we would want to do is get the q's together on one side. So I would subtract 9q. So I'd have -5 equals -7q. Now we divide by -7. That turns out to be +5/7 equals q. Or, there's my doorbell. Over here, we subtract 9q again. So we've got -5 equals -11q. Divide by -11. That turns into +5/11 equals q. And remember, once you have this answer, always make sure that you check your answer to see that it works. And if you plug these in, you will see that 5/7 and +5/11 both work when you plug back into the original equation. Number 43 works the same way. We're going to skip number 43. Again, if you have questions, please make sure you ask in class. And that concludes part 4 of Chapter 1 review.